Hi, geometry folks. We've got a special guest star today. Guest visitor, the Tinkerbell. This is the grumpy kitty that lives in my house, and I brought her favorite thing, the brush. Oh, yep, she's trying to get the brush. Here you go. Little brushing for the kitty. This is our old grumpy cat that hangs around our house. She is, gosh, she's older than some of you guys, I think. She will turn 16 this summer, so she's looking forward to getting her driver's license. And she's old and grumpy and does what she wants to, but she does love her brush. This is the only thing that really makes her happy. This and some treats from time to time. But she's just a weird cat. She doesn't even eat canned food. She won't touch it. If it's not dry food, she walks away, turns up her nose, and treats us like we just abuse her. But she's all right. Her name is Tinkerbell. She goes by Tink, Stink. I know. We call her Nuggets a lot too. It's kind of short for butt nuggets because of her attitude. Oh, I'm sorry, you didn't hear that, did you? All right. Well, I'm going to put her down, let her run away, and we're going to. Don't hiss at me, you old crabby thing. All right. I'm going to put that on the floor. Go down there with your brush. All right. Where was we? Oh, yes, we are continuing on looking at our circle unit. Good stuff. So let me switch over here and see what we're looking at today. All right, we are looking at quadrilaterals in circles. We have looked at chords, central angles, inscribed angles, diameters, radius. We've looked at that a lot this year. But now we're going to look at quadrilaterals in circles. All right, so we can inscribe a quadrilateral inside of a circle. Let's look at this. For each quadrilateral, use a compass. I'm not going to dig out the compass. I've already worked some of this ahead of time because I don't want to take that much time for you. Use a compass to see if you can draw a circle that would pass through all four vertices of the quadrilateral. So what do you think? Could we do that? Could you make it? Now this looks like it's probably pretty easy, right? If we did that and got our compass out and made a circle, it would probably catch all 4 points, you think? How about this one? Maybe. Well, I've done that for these, and let's see what it looks like. What we're seeing is, oh yeah, the square works real nicely, right? We've got this inscribed square. All 4 points of the square, the quadrilateral, are on the circle. Same with the trapezoid here. It works nicely, but when you do just a parallelogram that's not a rectangle, not a square, it doesn't work. It doesn't work. Not all quadrilaterals can be inscribed. An inscribed quadrilateral is very specific quadrilaterals that work. And a lot of them work. It doesn't have to be a square rectangle. It can be a weird shaped one. It just has all 4 points on a circle somehow. It doesn't have to be evenly shaped. But there's a lot of them, but not all of them. Don't just assume if I have a quadrilateral, it's going to work to inscribe it in a circle. But we're going to look at ones that do work today and talk about what can we learn about those. Because again, using circles, we can get so much good information. So let's remember this, that some of them work, not all of them do. So, looking on to the next one. Oh, Kitty's just laying down by the door saying, oh, I'm too tired to get up, but let me out. I'll let her out in a minute. If she don't get too grumpy first. All right, inscribed angles and circumscribed circles. So this shows 3 quadrilaterals with circumscribed circles. All right, here's a quadrilateral. Again, that kind of looks like a kite. May or may not be exactly. Here is a shape. Here's another shape over here that resemble trapezoids in quite a ways. Look like maybe off a little bit from being perfectly. But all of these are circumscribed shapes. These circumscribed circles around a quadrilateral. So for each one, let's highlight the arc. Yes, I hear you, Kitty. Let's highlight that. I'm going to get my highlighters, and we're going to highlight the arc from S to Q, passing through. Oh, somebody's got to go outside. Hold on a second. She don't want to be trapped in here with no school. No school for you. All right. She's out of here. No school for her. She has learned enough. No geometry. Unless she could be in charge, then she'd be happy to do this all day. But since she's not in charge, she's leaving. All right. Highlight the arc from S to Q. S to Q, passing through P. See, that's important because I can go from S to Q 2 different ways. I can go this way or I can go this way. If I go this way, That's the shorter way. It's less than 180 degrees. That's a minor arc. But on this one, we're looking for the major arc, the one that's more than half of the circle, passing through P. So this is the arc from S to Q that passes through P. On the second one, S to Q would be this one, right? Passes through P. And here, S to Q passing through P would go this direction. Could have been a lot shorter going through R, but they want the one that goes through P in all of these. So there are the 3 arcs that we are asked to mark. So then it wants us to find the measures. Oh, now we got to know how big these are. The arc that we highlighted. So what is the measure of that arc? Well, if we remember, the measurement of an arc is equal to the central angle that it's formed by. I don't see any central angles. I do see inscribed angles. Inscribed angles, if you remember, are formed by all points being on the edge of the circle. It makes this a chord, and this is a chord. And so those 2 chords combined at that central point, the vertex, make an inscribed angle, because they're all inscribed on the circle. But that is not going to be this arc. Now, we do know that with a central angle and inscribed angle, there's a relationship. Let me go ahead and just for this first one, I'm going to draw the central angle. Since we have the center of the circle, we can make the central angle that goes with that inscribed. All right, and so since we're talking about, there you go. Since we're talking about this angle, the central angle would be this one, right? That great big angle, because it's going from there to there. And how big would that be? I don't have a protractor. We don't need a protractor, because if we remember, an inscribed angle is half of what the matching central angle is. So this is 105. That means this is 210. And since that's 210, the arc that it defines also is 210. So this is a 210 degree arc. Ah, very nice. It's basically twice whatever the inscribed angle is. The arc is twice the inscribed angle. So on this one, S to Q, we can see is formed by this inscribed angle. It goes from that point to there. This is 62. So that means this would be twice that, or 124. 62 plus 62. 62 times 2, whichever way you want to do that. And 130, that goes from here at S to here at Q. That's that angle. So that means this is 260, because it's twice what the inscribed angle is, and equal to the central angle, which is not drawn. All right, so we've done that. We have found the measurements of the arcs. The other arc from S to Q. So what would the other one, the one that we did not highlight? Let's highlight in another color just so we know which one we're talking about. The S to Q would be the blue one in each shape. That would be the other arc. I'm going to highlight that there to show which one we're talking about. So if this is 210, how much is the blue one? It's a circle, right? Together they make a complete circle. So a circle is 360 degrees. 360 minus 210, so this is a 150 degree arc. 124, if we need it to be 360 for the whole circle, 360 minus 124 is 236. That's a 236 degree arc. And this one's 260. We need it to be 360, so we need 100 would be the blue arc. That would make that work out. So that works right there. How about angle SPQ? Where is SPQ? Well, let's see. We got this other highlighted. P is in the middle. So that means that is the middle of the angle. The letter that's in the middle matches the vertex. That's the middle of the angle. So S to P to Q, they're talking about this angle. All right. S to P to Q, they're talking about this angle. S to P to Q, this angle. All right, so P would be the center of the angle. That's the point where it turns. So what is that angle equal to? I don't know. Yeah, I do know, because I know that the arc, see, that goes from there. That's the blue arc. I know the inscribed angle is half of what the arc measures. So if that's 150, this is 75. That is 75. If this is 236, then this angle here is 118, because that is half of 236. If that one is 100, then the angle that it's defined by is 50. It's 50. See how that works? We can learn a lot by inscribing angles, inscribing quadrilaterals. Tells us all kinds of things. And this is just pulling out some of the basic stuff here. So let's move on to this. Here's another quadrilateral with a circumscribed circle. Okay, so it's an inscribed quadrilateral. What is the value of A plus B? Right here. Omega plus beta. These are Greek. If we add this angle to this angle, you're like, I don't know. It didn't give me any numbers. How am I supposed to add it together? That's where we use what we know. This angle is going to be half of whatever this arc is, right? So yeah, let's do these in different colors. Let's do this one right here. So it's going to be half of whatever this arc is, and we don't know what that arc is either. We just know that that angle is half of it. This angle is going to be half of whatever this arc is. Okay, I don't know what that one is either, so I don't know how that helps if I don't know what that angle is. Well, here's how it helps. They didn't ask us what is omega equal. They didn't ask what is beta equal. They didn't ask what those individual. They asked what do they equal if we add them together. Well, if I add them together, that means they're half of these added together. And we know if we add that together what they equal, right? If we add those arcs together, that equals 360. So if we get half of that, those add together to be 180 degrees. A plus B. The omega plus beta is going to equal 180 degrees, because it's going to equal half of the circle. So if they're across from each other, they're going to go, what about this way then? Would those also equal? Well, it has to. A quadrilateral is 360 degrees inside. Think of a square, 90, 90, 99, 360. All quadrilaterals add up to 360. So if these two is 180, then the other two have to be 180. Wow. Did you notice that back here? Did you notice that? These angles were opposite in the inscribed quadrilateral. This one's 75. That one's 105. That added to 180. This one's 62. The opposite one is 118. This one's 50. This one's 130. Those are opposite. So notice if we look at, this is P, Q, R, S. We added P and R. Not two angles side by side. These are two angles that are across from each other. They're diagonally across from each other. They're supplementary. They add up to 180. And that means Q and S would also be supplementary and add to 180. Now, we're not saying P and Q add together to be 180. We're not saying R and S. Those are not Q and R. Not ones right next to each other. Those are only if it's a square or a rectangle will those add up. But these are not squares or rectangles, so they're not going to add up to 180. But opposite ones. So if you skip from P and R diagonally, then it works that way. All right. So we see that. Let's move on. Okay. Here is a cyclical quadrilateral. That means it can be inscribed in a circle. Cyclical quadrilateral. So, draw diagonal B to D. All right, I'm going to go ahead and do that. We're going to draw this diagonal. B to D. Okay, that's the diagonal, right? A, B, C, D. I went from B to D. I didn't go A, B. I didn't go B, C. I skipped from B to D. How will this diagonal relate to the circumscribed circle? Explain your reasoning. I don't know. Is that a diameter? Is it a chord? Well, we know it's a chord, right? Because we know this is going to be on the circle and this is going to be on the circle because it is a cyclical quadrilateral. We know it's, let me get that. We can see that better. We know that since all four of these points are on the circle, that is a chord. But the question is it a diameter? How would we know? Here's exactly how we would know. See this angle here? 90 degrees. If this is a circle, that means this point's on the circle, this point's on the circle, and this point's on the circle. That makes this an inscribed angle. If we had the circle there, we could see that's an inscribed angle. So since it's an inscribed angle, it's going to equal half of the central angle. The point that goes through the center to those same 2 points would be double that. Well, double 90 is 180. So the central angle is 180. So that means from here to here, the angle formed there's 180. What's a straight line? So this must go through the center of the circle. That has to be a diameter. This has to be a diameter. So we know that's going to be 180 because this is 90. So construct the center of the circle for quadrilateral ABCD and label 0. Well, since we know this is a diameter, we know halfway in the middle of that has to be the center because a diameter would be the full width of the circle. So it's going to be right there, right? I took a measurement. That would be the center of the circle that would go around this quadrilateral. Why does that work? Because we know that's a diameter. And so if we cut it exactly in half, it's a radius that gives us the center. Construct the circle. All right, again, I didn't want to take the time to do that with a compass, so I've already done that on the computer, and we're just going to swap it out. All right, so we took that and we have swapped it out. There is that center point with a B to D already right there, and now we've added the circle around it. And we can see the circle goes through all 4 points, and this would be the center of the circle. So could we follow this procedure to construct a circumscribed circle for any cyclical quadrilateral? Well, let's go back and see. Let's say if we just started with this one, all right, before we get to the point that we put in a circle. And we said, okay, we're going to draw the diagonal from here to here and find the very center and make the circle, and that will be, the midpoint would be the center of the circle. Is that going to work for anyone? Let's see. If we did that, let's draw that diagonal. And the midpoint would be about right there. Does that look like the center of the circle? No, that can't be the center of the circle, because look, over here, it's a lot closer than over here. The center would be over here. This is about the middle. So it's off. It's not in the center. Why did it not work there, but it worked on ours? It's because this is not a 90 degrees. Since that's not 90 degrees, then this cannot be a diameter, the ends of that circle. The circle that would be made from the central angle to the same 2 points would not be 180 degrees, would not be a diameter. It would be twice whatever this angle is. And since that angle is not 90, it's not going to be a 180 degree line. It's not a diameter. So that only works over here. This is only going to work when the angle formed is 90 degrees. Now notice this one's not 90 degrees. They don't both have to be 90. But if you find one that's 90 degrees and you make that chord, which is a diameter, you know it's going to be a diameter because of that 90 degrees. You know it's going to be 180 degrees. So a little something that we can learn about circles. Again, we don't want to make assumptions that, oh, if we can just do that diagonal and make a circle, that's going to be the center. Special conditions. Only certain times is that going to work. So pay attention to the little details. Like anything with math, just because it works for this doesn't mean it works for every case. It doesn't work necessarily for every case. You got to look for those little details. Is that a 90 degree angle? Oh, then this is going to work. Otherwise, it's not going to. So All right, well, I'm going to go find the cat and apologize. She's probably mad at me for making her stay in this room too long because she wanted to leave, and I didn't immediately jump up and bow to her command. But that's what we live with around here. When you have 16-year-old grumpy cats, they're in charge. You don't have a choice. So we'll see you next time. Do work you can be proud of.